Time and Date, we look up into the sky. We bring you exclusive footage from eclipses worldwide. We take our mobile observatory to where the action happens. Hi, Steffen.
Hi, Anna.
We collaborate with experts and observatories across the globe to bring you the best view of celestial events.
And we ordered the Devil's Horn just for you.
Now, we have to say thank you very much for your images tonight.
We explain how and show why it all happens while answering your questions during our live broadcast events.
That is a meteor.
Find your home and even more details on Time and Date. And subscribe to join us next time. Welcome to tonight's Total Lunar Eclipse here on timeanddate.com. I'm Anna Buckle. This is Graham Jones, and we're in for 4 hours of full moon fun. We have telescopes on the ground in California, New Mexico, Hawaii, and Western Australia, and we have some exciting interviews coming up, including one with Dr. Noah Petro of NASA's Artemis program, which is sending people back to the moon. But first things first, who gets to see this lunar eclipse in real life? Well, a lunar eclipse happens when the sun, earth, and moon line up and the moon passes through Earth's shadow. So the sun and the moon are on opposite sides of the globe. That means tonight it's a full moon. We're looking at one right now. And you have to be on the nighttime side of Earth to see a full moon, not the daytime side like here. Right, Graham?
Yeah, so Anna, we're here at the Time and Date HQ in Stavanger, Norway. For us, it's 10:30 in the morning local time. That means that we are on the wrong side of the planet for this eclipse. We are pointed towards the sun at the moment, not the full moon. So the question is, who is looking at the full moon at the moment? Well, for that, we can take a look at our moonlight map, which is just there above us on the screen. Now, on this moonlight map, the light area, that shows the region of the globe where the moon is above the horizon at the moment. And we can see that that's basically the Pacific Ocean and the land around it, North America, South America, eastern part of Asia, and Australia. In the middle of the map, we have that little moon symbol. That indicates where the moon is directly overhead at the moment. In other words, you have to look straight up to see it. That is pretty close to the islands of Hawaii.
Yep.
So that means that in Hawaii, we're around about midnight, and the full moon is really high in the nighttime sky. Now, Anna, we've got to remember that this is a live map.
Yeah.
Over the course of the next 4 hours, it is going to be changing. The Earth is going to be spinning, and that means that the light area where the moon is visible, that's going to be slowly shifting to the left. And that means that, well, basically the moon is right now, it's rising across the eastern part of Asia and across Australia.
It is.
And in Perth, for example, where we have our
Telescope.
feed coming from there, we can't actually see the moon right now. We're waiting for the moon to rise in that part of the world.
Yes, because we have telescope images coming from 4 locations, as mentioned earlier. We've got the Time and Date Mobile Observatory in California. That's Steffen, Thorsen, and Konstantin Bikos. They're on their 5th time in the US in the last 3.5 years. And we're going to be talking to Steffen and Konstantin later in the show. In Santa Fe, we've got John Williams. This is the 3rd time we're working with him. He's an award-winning science writer, and he does amazing work in the area of astronomy outreach. He's streaming from Santa Fe, and we can actually see his moon up here. in the little window above us on the screen. And then we have been looking at a beautiful moon from Waimea, Hawaii. There we're working with Preeti Krishnamurti and Avinash Surendran, otherwise known as the Starry Knights. And it's the fourth time we're working with them. And we're going to have a chat with them fairly soon in the show. And in Perth, you mentioned Perth. They're still waiting for the moon to rise. We're working with Matt Woods from Perth Observatory and his streaming partner, Roger Groom. And it's our 9th time working with Matt. And it's coming up to the end of daytime there. It's coming up to moonrise there. And it's rising in about an hour or so from now. But first things first, we have some housekeeping to do.
We do, yes. So just to run through the timings for tonight's eclipse. On the screen in the bottom right corner, just below us, we have our UTC clock. So this eclipse is happening across many different time zones, and people are watching this live stream across many different time zones. So we are using UTC as our reference time. That is the world's time standard. Over on the left-hand side of the screen, we have our timeline, which shows the different stages of this eclipse. Looking at the timeline, we can see that the eclipse has already started. We're in the first penumbral phase of the eclipse. This is where the moon is moving through the lighter outer part of Earth's shadow. There's normally not so much to see during the penumbral phase. Things really start to happen when the partial phase begins. That is happening in about 15 minutes time. That's when the moon starts to move into the darker inner part of the moon's shadow. And well, Anna, looking at the screen, we can see that on the left-hand side, the moon is noticeably darker. That is showing us that that dark part of Earth's shadow is approaching. Exactly. Totality is beginning at around 11:04 UTC. That is when the whole of the moon's face has been covered by the dark part of Earth's shadow. And it's around that time that we see the moon take on this famous sort of blood red tint. And tonight, Totality is going to be lasting for just under 1 hour. And then looking again at our timeline, around 12 UTC, we move into the second partial phase as the moon begins to then move out of Earth's dark shadow once again.
And so why does the moon turn red? Well, we're going to be talking to Preeti and Avinash in Hawaii about that and ask them the question. And that's going to be in about 10 to 15 minutes, depending on when we catch up with them. So we'll see you back here soon. And don't forget to subscribe to our YouTube channel. You're watching Total Lunar Eclipse here on timeanddate.com. And as you can see from our timeline, the partial eclipse has started. We're looking at a beautiful full moon here from Waimea, Hawaii. And I want to go like and blow away those clouds. The moon has started to move into the dark inner part of Earth's shadow. We're about 1 hour from totality, where the dark shadow will completely cover the moon, and that will be the start of totality, and the moon will take on that blood red color that we're so excited about. And why does the moon turn red? Well, we've got the people who can answer that with us on our air and soon on the screen, right, Graham?
Yeah, we certainly have, because this great image we're seeing from Hawaii, this is coming from some old friends of Time and Date. So Preeti Krishnamurthy and Avinash Surendran, they both work at Keck Observatory on Hawaii's Big Island. It's one of the biggest and most famous observatories in the world. And well, when they're not working professionally, Preeti and Avinash, they're doing all kinds of cool things in the world of astronomy education. And there they are known as the Starry Knights. And they are going to join us now.
Hi, you guys.
Hello.
So it's midnight. Hi. So it's midnight in Hawaii. And can you tell us where you're streaming from tonight?
Oh, Lord. Preeti here. Hi, everyone.
Hi, Preeti.
And, from our home in Waimea. It's a little town towards the northern side of the big island of Hawaii. We have a telescope just set up in the backyard where it's cold, and we are sitting inside the house where it's warm and cozy.
Oh, that's
And,
perfect.
yeah.
And we worked last with you back in November 2022, but you guys have been doing a lot with the Starry Nights since then. Can you tell us a little bit what you've been up to?
It's kind of a mixed answer. We've been up to a lot and nothing, because a lot of it has to go with brainstorming. We've been kind of renovating and revamping how we want to do things. We did focus quite a bit on live streaming previously, and a little bit of Starry Nights was focused on informing people about upcoming events. But I think there are enough platforms doing that now. The whole world is excited about astronomy, so there are enough websites now letting people know that something is going to happen. So we thought maybe we will move a bit away from that, try something new. And around that same time is when we got our C Star. So we've been experimenting with it, and tonight's live stream is one of those major experiments, and we are
Very
glad it's
cool.
going well so far.
Yeah, the new telescope has been really good.
Yep.
In terms of actually showing people, like what we do is we go on outreaches and we set up
We are changing the way we do our sky watches, for example. Previously, we used to do our sky watches with optical telescopes, but we do not want to take away from that. But the C Star is a nice new addition. So when we do sky watches now, we do it with our C8, our Celestron C8, and we also add the C Star to it. So we go
Very
visual
cool.
first. We ask people to look at the image visually. If they are looking at, let's say, Cat's Eye Nebula, they look at it visually, while the C Star is stacking images on the side. So we let them
Super
look at the
cool.
visual image and then look at the stacked image, so they can understand the difference between what a human eye sees and what a mission sees, and why we need telescopes with cameras and not eyepieces.
Super
It's
cool.
been a
That's really nice.
Give
That's
our
yeah.
perspective.
Yeah, that's a great way of doing things. Yeah, and and we're certainly enjoying the image that you're sending through here tonight. We've got that little bit of a shake. Avinash, we were just talking earlier, and you were commenting that there is a lot of wind in Hawaii.
Yep. Waimea is always windy, unfortunately. It's always windy. We can't escape.
Yeah,
we have learned to hold on to caps and glasses and bags when we walk out every day.
Oh, right, absolutely, yeah. Now, I mean, you do all this great work in astronomy education, so we have to ask you guys, when people ask you the question, why does the moon turn red during a total lunar eclipse? How do you explain it?
I'll start it off and then I'll leave the technical part to him. Yes, I mean, this is a question that's been asked often, but then the response can get repetitive, and we recently dealt with this question too because we gave a public talk on lunar eclipse and the blood moon. So one thing that we came across during this time that I thought was exciting was actually a visualization which was created by NASA for one of their previous total lunar eclipse, one of the blood moons. And it basically shows a lunar eclipse if you saw it from the surface of the moon, which is the moon's solar eclipse. But let's say it's lunar eclipse time, but instead of standing on Earth, you're standing on moon and you're watching it. What would that look like? The blood moon in reverse. So that was a beautiful video to me that explained what I already knew, but in a different way. But I think he can explain it in a more
Yeah, so
technical manner.
it's really beautiful how that video shows that when the Earth eclipses the sun, you expect the Earth to completely shadow the moon, right? I mean, that's what you expect. A bigger object shadowing a smaller object kind of thing. But we always forget about the Earth's atmosphere. And the Earth's atmosphere refracts light from the sun towards the moon, and the Earth's atmosphere turns a complete blood red when you see it from the moon. It's like you are seeing 1,000 sunsets from all over the Earth shining on the moon. That's the effect. That's literally what it is on the moon. Like all over the Earth or the boundary where the atmosphere comes through, the sunlight is coming at an angle where it's very similar to the sunset, where we see the red color of the sunset. And imagine all the 1,000 sunsets of the Earth illuminating the moon. That feels so beautiful when you
Because
visualize it like that.
it's the same reason why you have a red sunset and a blue sky. It's the same reason. But now, instead of the sun setting just happening in one spot on Earth, you're seeing all of that on the moon from the surface of the moon. So I think it's a really interesting way of looking at the blood moon from the perspective of the moon, and the Earth's atmosphere becomes red in color, like how you would see the ring of fire during a solar eclipse. That's a version of that.
Yeah, that's a great way of thinking about it. Absolutely, yes. And we of course have this to look forward to tonight in around about an hour's time when Totality starts.
We do.
Yep.
I'm just a bit awestruck by that image, actually. I think it sounds beautiful. But thank you, Preeti, and thank you, Avinash. And we're going to let you get back to stabilizing that telescope in the wind and continuing to blow away the clouds like this. We're going to be back on timeanddate.com here with the total phase of this lunar eclipse. We're going to be talking with NASA's Dr. Noah Petro in about 15 minutes. He is part of the Artemis program, which is sending people to the moon soon. So we will see you back here. You're watching timeanddate.com. We're watching a beautiful lunar eclipse going on here. We're about halfway through the first partial phase of the eclipse. We can really tell that that dark inner part of Earth's shadow is creeping deep onto the moon, and it's covering about half, but it feels like a lot more at the moment because it's a very blurry shadow what's going on there. We're also halfway to totality, so that's when the moon is completely covered by Earth's dark shadow and it turns blood red, and we've been enjoying watching the moon here on our screens, but there's also a lot of moon in the news recently, Graham.
There is a lot of moon in the news at the moment. Yes, so NASA's Artemis program is sending humans back to the moon. So the Artemis 2 mission, that's going to send 4 astronauts on a flyby around the moon, possibly as soon as next month. In 2027, we'll have Artemis 3, which is a test flight in low Earth orbit. And then in 2028, Artemis 4 is going to see humans walk on the moon once again. Now, Dr. Noah Petro is the chief of NASA's Planetary Geology, Geophysics, and Geochemistry Lab at the Goddard Space Flight Center near Washington, D.C. He's the project scientist for the Artemis 4 mission. He's responsible for putting together the science program for when astronauts land on the lunar surface again. Anna, we talked with Noah back in 2022, just before the launch of Artemis 1. And here we are on the brink of the launch of Artemis 2. And Noah has very kindly agreed to come back and talk with us again. And there he is. Hey, hi, Noah.
Good to see you, Noah.
And what a spectacular shot you have here. Oh, it's so stunning.
Oh, it is looking so great there. Now, Noah, you are near Washington, D.C. For you, it's just after 5:30 in the morning. So you're kind of heading towards daybreak. The moon is going to be setting soon. Have you been able to catch any of tonight's eclipse from your location?
Unfortunately, no. Went out earlier, and we have a nice little snow layer on the back deck and a high cloud cover. So we are being eclipsed by Mother Nature, but Mother Nature always wins, and that's okay. I get a great view here, and I'll take that for today. I will say it's ever so slightly disappointing, but my 7-year-old son, so the last time I did this, he was a little bit younger. He's now old enough to get excited for eclipses. And he's old enough now to also get disappointed by eclipses. So he's learning some valuable life.
Yeah. And speaking of disappointment, the Artemis 2 launch, there have been possible launch dates, February, March, now potentially April at the earliest. There's been some changes for the plans for Artemis 3, Artemis 4, and, changes, delays. And how is that for you guys working in the Artemis program?
The changes that were announced last week, introducing Artemis 3 and basically pushing back my mission to Artemis 4, we accept that. It's a good addition. It introduces some new testing to the program. We welcome that with open arms. The delay of Artemis 2 in launch can be personally frustrating. For those that are working closest to the mission, it becomes great uncertainty in your life. When is this thing going to happen? And there's this anticipation, but we understand it. It is the name of the game. Safety is the most important part of the mission. And until all of the pieces come together and work properly together, we can't have a mission. We, on the science side, have been working towards Artemis 2 now for over 2 years, and waiting another month, waiting a little bit longer for that ultimate satisfaction of having humans fly by the moon. is worth it.
Mm.
That said, it does introduce great uncertainty, and uncertainty breeds anxiety. So we just try to keep ourselves level, and it's great lessons in there for life, for management, of how to properly manage your own expectations.
Yeah.
With delayed Artemis 2, we can prepare for new launch dates. The team that's working very closely on it also can, practice again and get better prepared. So, there are silver linings behind all of this. We get a little nervous with each delay because it says, okay, the visibility of the next launch window is going to change a little bit. I think we were all very excited for the initial launch window because basically the crew would have had a perfect view of the far side of the moon. And now with each subsequent delay, the view of the far side changes a little bit. But we have to prepare for that, right? And always going back to the notion that Artemis 2 is a test mission. To get to Artemis 4, get to Artemis 3 and 4 and 5 and beyond, Artemis 2 has to work. So we know that there's a bigger picture at play than just the picture that we want of astronauts flying by the far side of the moon for the first time in over 50 years. But it will be worth the wait. And when that rocket launches and those incredible 4 astronauts are on their way first to the moon and on their way home, it will have been worth the wait.
It definitely will. And those 4 might be going already next month if everything is set the way it should be. And what can you figure out science-wise during a flyby like this?
Yeah, so thinking back to even Apollo and what was learned by sending humans first in orbit around the moon on Apollo 8 and later on Apollo 10, we're trying to make the most of this opportunity. We have 50 plus years of lunar knowledge. So it's not like we are sending astronauts to take images of the moon for the first time, but having human observers there for the first time in 50 years with their unique perspective gives us an opportunity. I want to be very careful to manage the science expectations. We get excited. Hey, we're going to be able to do new things. It is a test mission. And they're not able to bring along 53 of their most favorite science experiments to bring with them. The key science experiment that we're bringing is the human observer.
Yeah.
For very well-trained astronauts, 3 of whom have extensive experience orbiting the Earth, will have an opportunity to practice their craft of planetary observation around the moon. And so we're really focusing on lunar observation, lunar photography. Now you might say, well, we've been orbiting the moon with the Lunar Reconnaissance Orbiter now for over 15 years. What more can we learn by looking at it? Well, it's really looking at it with the human eye. So it's looking for color differences, texture differences. As they pirouette around the moon, their observation angles will change. The sun will mostly stay in the same position in the sky relative to the surface of the moon. So it's looking for changes that the human eye can perceive as their angle changes looking around the moon, basically photometry, photometric effects, and then documenting them. So it's not, we're not sending a multi-million-dollar detector around the moon. Actually, we're sending multi-billion-dollar detectors in the form of the human eyeball. When the eyeball is tracked to a well-trained brain and you have crew observing, we have an opportunity for new types of observations. I think there's also the very selfish advantage of having 4 well-trained astronauts on a global stage talking about the moon for several hours as they fly by. And the repercussions of that. It's not science, but it means that kids from all around the world will be tuned into science. Hopefully they're tuned in here today as well, but getting that reinforcement of, oh, here's a destination, listen to their enthusiasm. They're looking at the far side of the moon and kind of reintroducing the moon to an entire, multiple generations of people.
Yeah.
And what comes from that.
Yeah. Wow. And looking ahead to your mission in 2028, Noah. So you're the project scientist for Artemis 4. We're going to have 2 astronauts landing on the moon's surface. So this is like the ultimate geology field trip. I mean, how do you go about planning something like that?
Yeah, I mean, it's a challenge. We start with a list of all of the things that we want to do. with sampling the lunar surface, an area at the south pole of the moon. We start with possible instruments to leave behind. We have 4 selected instruments that we might be able to carry with us. And we start with basically the wish list. If we had everything we wanted, what kind of samples would we want to collect? From what locations? How would we deploy the instruments to maximize science? And that's my job. And when you say your mission, it gives me goosebumps. I mean, I'll be very humble about it. It is not my mission. It's the collective mission. It's the scientist's mission. It's the world's mission. And I'm just in a fortunate position to try to make it happen. And so we talk about, well, what kind of samples do we want to collect? You know, we want to go get chunks of rock. Boy, it'd be great if we could bring back a fragment of rock this big. But if we take a rock this big, this is relatively heavy. So we can only take so many of these size samples. If we take 2 rocks of this size and 10 rocks of, you know, soil size, we have to maximize the return without basically spending all of our time collecting big rocks, meaning we get fewer total number of samples. So right now we're in the process of basically strategizing. How do we get the most science return for the limited amount of time that we have on the surface, so that we, you know, have a mission, not just that we're proud about, but that has massive science return. You can look back to Apollo when it was done with each mission, and they might not have always been science focused. Apollo 11 was a test mission. Artemis 4 will be a test mission. Apollo 11 maximized the science that they got out of that limited amount of time that Neil and Buzz were on the surface. And we're really trying to think of how do we do the same thing for Artemis 4. By the time the next total lunar eclipse happens in December of 2028, we will possibly have had landed 2 missions on the surface of the moon. How do we use that first mission, Artemis 4, to best prepare for Artemis 5, 6, and 7 and beyond? And so part of what we're also doing is looking at testing new systems and new ways of doing things so that when we do them again on future missions, we're buying down risk. So this is I would say kind of the fun part, because it's strategy. It's a little bit of I don't want to minimize it, making it sound like it's trivial, but gameplay. Well, if we do this, this, and this on this first mission, we don't have to do that on later missions, or we can do things differently and learn perhaps where we could find efficiencies. So right now in Artemis 4 planning, we're looking at, okay, how do we get the most sample, the most science out of this, you know, relatively limited amount of time that we have on the lunar surface. And that's where the fun comes in, because it's, you know, it basically means, well, if we collect this type of sample here, we get 2 or 3 possible avenues for science, rather than saying, well, if we get this one sample, it's really limited the type of things that we want to do, because we're not just planning a mission for ourselves, but for the scientists, the future scientists that are watching this eclipse happen, to get excited to go off into a career in science and engineering, so that they can go study our samples 10, 20, 30, 40 years from now as well. So trying to think of things that we might not totally understand, but future generations will be able to get the samples and figure out the mysteries of the moon and the inner solar system.
Yeah, well, and Anna, I'm sort of getting goosebumps myself.
Me too.
Here.
Me
and
too.
I mean, and also just that thought that the next time a total lunar eclipse rolls around at the end of 2028, to think that we might have landed twice on the moon.
Yeah.
By then, wow.
We can point out on the screen where they've been. That just gives me shivers as well. I love it. I love it. Thank you, Noah. This is just super fascinating. I wish we could talk another hour on this subject. But good luck to you and the Artemis team. We've got our fingers crossed for everything going smoothly, and for you guys managing your emotions and your expectations leading into a very exciting time for the moon indeed.
Yeah.
No, it's first of all, it is a delight to share this specific moment with you and with everybody who's watching. It's also, I'm future excited for sharing those future successes with everyone, because as I said before, you know, it's not really my mission. It's all of our collective mission, not just lunar enthusiasts, but everyone who might have even the slightest interest in the moon. It's really about not just getting people back to the moon, but getting people back to being interested in the moon as well. Because me personally, and I can imagine for you all as well, that you know, I get up at 5 a.m. to try to catch a glimpse of a lunar eclipse, not just because I'm passionate about the moon, but also sharing something with the collective, right? The people all around the world can participate in this particular event. Gives me great hope that people all around the world will be able to participate in Artemis 2 and 3 and 4 and 5 and beyond, and that truly can bring us all together. Cloudy skies or not, it might be cloudy here, but it's not going to be cloudy here forever. And I'm very much looking forward to celebrating those future successes with you all.
Yeah. And so remember, if you are able to see this eclipse in real life, go outside, look up and see the moon turn blood red fairly soon. We're coming up to totality at 11:04 UTC. So that's in about 15 minutes or so. So it's not too far away. I'm very excited. So stay tuned to our live coverage here, Noah. You can watch the moon turn red here with us on timeanddate.com. And stay here as we head towards totality, and we will be back later. Totality across the board here on this total lunar eclipse on timeanddate.com. And very jealous of the people that can see this in real life. It looks amazing on the screen, but real life is a whole new ball game. So if you're there, look up and take a look, because it's amazing. We've got just under an hour of this to enjoy, of these blood red moons across the board, including on our moonlight map. There you can tell that the totality is happening right now. Now, we've been seeing images from California, from Hawaii, from New Mexico, and you might have heard that we were talking about Australia as well. Perth, Australia, and the moon has risen. We've got Matt Woods and Roger Grooms. They're set up in Matilda Bay, which is west of Perth city centre, and they're looking across the bay to the eclipsed moon. Now, it's still twilight there. It can be difficult to spot an eclipsed moon during twilight because it gets much, much darker than a normal full moon, but we're going to see it as the moon climbs higher in the sky. And you might have spotted a bonus stream. It says Dunedin, New Zealand here on the screen. And we didn't mention New Zealand earlier in the show, did we, Graham? But
Yeah, so this is a great bonus feed we've got from our friends in Dunedin on New Zealand's South Island. So this is coming from Warren Hurley, Anton Stuck, and Linus Molteno at the Dunedin Astronomical Society. Now, Anna, you may remember them from September last year, when we had that partial solar eclipse that was more or less only visible from New Zealand. And our friends there in Dunedin sent us some fantastic images of the partial solar eclipse last year. Of course, their main thing is that they are counting down to a very big solar eclipse that's coming up in 2028, in July 2028. That's when we're going to have a total solar eclipse across Australia and New Zealand. Path of totality comes across Australia, goes over the city of Sydney, then continues to New Zealand, and the last city on the path of totality is Dunedin. So they have a big countdown going on there in Dunedin.
And they're getting all their practice in right now.
Getting it right, just getting in some more great practice tonight. Exactly. So we are going to be hearing lots more from Dunedin over the coming years. So we have lots of views of totality to enjoy here. As you said, Anna, totality is going to be lasting for another 50 minutes or so here. So stay with us. Enjoy this here on timeanddate.com. Don't forget to subscribe. And Anna and I will be back soon. Wow, we are enjoying Totality here on timeanddate.com. We are about halfway through the total phase of this eclipse. That means that we're around the maximum point of the eclipse, where the moon takes on its most reddish tint and also becomes the faintest in the sky. Now, we were hearing from our interview earlier with the Starry Knights that this reddish tint that we see during totality, it comes from light being filtered through Earth's atmosphere. Interestingly, it's never quite the same from one eclipse to the next. And it's never quite the same looking at it from different places in the world. And as we're also seeing it here on the screen, we've got that we've got the image from Dunedin in the corner. We have the main image coming from California. We are seeing a slightly different shade there. This kind of thing does also depend on what kind of equipment people are using to stream these images. And it's always very different when you see things in real life as well. So, of course, one of the big questions is, how does this look in real life? How does this image from Yucca Valley compare to what people are seeing on the ground? Well, the person who can tell us that is one half of our Time and Date mobile observatory team, Konstantin Bikos. And Konstantin is going to join us now.
Hello.
Hi, Konstantin.
Nice to see you.
Nice to see you too. How's it going? It's about 3:30 in the morning there in California, and it looks a bit cold. And you've been traveling all the way from Stavanger, Norway. So, what time is it in your body? What time is it in the night? How are you doing?
Oh my God! Yeah, I don't know what my body thinks the time is really. It's these eclipse live streaming trips are fantastic experiences and adventures, but they do take it out of you. I'm kind of tired. I'm kind of cold, but I'm watching this fantastic eclipse here, and I'm so happy I'm here and able to watch it with my own eyes.
Yeah. I've been telling everyone I'm super jealous, and now I'm extra jealous. So thank you for that, Cosmo. You're in Yucca Valley. It's in the desert. It's about 2 hours drive from Los Angeles. This is your 5th trip to the US in just over 3 years with our mobile observatory. And how does this trip compare to the 4 others that you've been doing?
Yeah, I'm starting to feel at home. Yes, it's kind of crazy that I've been here so many times now. Well, it's both easier and harder, I would say, than previous trips. Harder in the way that I just told you that it is extra tiring, basically, because earlier trips we went to more eastern regions of the US. Now we're in California, so it's 9 hours difference. So it's really hard on the body, basically, but easier in a way that, first of all, I think we're getting a much more routine now. And in my humble opinion, we're getting quite good at this. So,
in our opinion, too.
Yeah. But also, we've been very lucky this time with the weather. So it's been much more predictable. We flew into Los Angeles, and for a week or so, the weather forecast was pretty stable for Yucca Valley and this region. So we were able to plan much more ahead than some of the last times where we had to travel through the day, and then on in the following night we had the eclipse to do. So now we had much more time to get used to everything and set everything up properly to bring you those pictures.
And we're back. And we're back. We lost everything there for a minute, but we are back online. Back with Konstantin Bikos, who is
Hello.
with the Time and Date Mobile Observatory in Yucca Valley, California. Konstantin, we were just talking about how the color of the moon compares, what we're seeing here on the screen compared to what you actually see when you look up and see the moon in the sky.
What can you see?
Yeah. So it was actually a little bit surprising for me to experience. I've seen a few now, and this feels a lot darker. So it is also a lot darker than you see on the screen. On the screen, we've enhanced the picture so we can bring out that beautiful red color a little bit more. But in the sky, it's actually on the dark half of the moon. It's actually a little bit hard to see it even. It's very dark.
Well, that is interesting. Yeah. And that is sometimes one of the surprising things with lunar eclipse is just how dark and how faint the moon becomes compared to a normal full moon brightness. Yeah. How was it during the partial phase of the eclipse? When did you sort of start to notice the moon taking on a reddish tint in the dark part of the moon?
It starts when it's past half of the moon, maybe covered by the Earth's umbra, the darkest shadow. You start to see a red tinge, and that gets more and more as the eclipse progresses. And now it's very, very red. It's clearly red and dark copper red.
Wow.
Yeah, that's great. And if you are on the nighttime side of the Earth, again, just a reminder that if you have clear skies, you will be able to go out and see this eclipse and see what the color of the moon is from your location. Also, just a reminder, again, that some of the different colors we're seeing on the screen are also coming from different telescopes and different kinds of equipment that people are using to stream tonight's eclipse. Konstantin, we know that you're super busy there, so we're going to let you go and get back to work. Keep enjoying Totality with us here on timeanddate.com. We still have another 20 minutes or so of Totality to enjoy, so don't go away, and Anna and I will be back soon.
Welcome back. We're at the end of Totality here on timeanddate.com. We're watching this deep, rusty blood moon from Perth. It's just looking super great. The full moon has been rising, the sun has been setting, and the sky is nice and dark, and we can really appreciate Totality from Australia here on the screen. Now, Matt and Roger, they have been doing a great job for us and working with us for the last 9 years, more than 9 years.
It's around 9 years. Yeah.
They're in Matilda Bay on the outskirts of Perth, and it's looking beautiful. But what we can see there, we've got like this bright side of the moon. We've got that crater there at the end, Tycho crater, if I'm not mistaken. And in Yucca Valley, it's the opposite. Tell me more.
Yeah, so we can see here that the moon appears to be brightening from opposite directions, as seen from Perth in Western Australia and Yucca Valley in California. And there are two interesting effects going on here. The first one is that Western Australia is in the southern hemisphere. California is in the northern hemisphere. And as we move from the northern hemisphere to the southern hemisphere, the moon appears to rotate in the sky and sort of appears upside down from the other hemisphere. But there's another effect going on as well. We can see this actually on the moonlight map that we also have on the screen there. To recap, our moonlight map, the light area on the map, that's where the moon is above the horizon and visible at the moment. And that includes both Australia and North America. But this light area on the map, it's slowly moving to the left as the Earth rotates, which means that the moon is rising in Australia. It's climbing higher into the sky. But in North America, we're heading towards moonset, and the moon is dropping down towards the horizon. And just as the moon appears to rotate as you go from the northern hemisphere to the southern hemisphere, the moon also appears to rotate in the sky as we go through the night from moonrise through to moonset. So both these effects we have working here to give us this this kind of mirror image of the direction that the moon appears to be brightening from in as seen from Australia and from California.
Yeah, and you know, when I'm in Australia, the moon feels upside down, never, depending on what time of rotation it is. But it does, it's interesting how it spins in the sky, but it's also flip round.
Absolutely.
So super interesting. But it's not only the moon's orientation that's interesting when we look at these images. First of all, we've talked a little bit about the color. We've got this deep rusty red from Perth, and then we've got this kind of almost brown from Yucca Valley in California. But sometimes we even see a tiny spot of blue.
Yeah, a little bit of blue in total lunar eclipses, a phenomenon known as the turquoise band, which it's never easy to spot. You have to be very lucky to catch it. But this happens because, well, we've talked about how this reddish tint is produced by light that's being filtered through the Earth's atmosphere and taking on this reddish tint. But around the edge of Earth's atmosphere, we have the ozone layer. Now, sunlight that's going through the ozone layer, instead of getting filtered to a reddish color, it's getting filtered to a bluish color. So when we think of Earth's dark shadow, the center of the shadow has this sort of blood reddish tint. But around that is this sort of bluish ring. And we can sometimes see this around about the beginning or the end of totality. That's when we we sort of see the edge of the Earth's dark shadow just moving onto or just leaving the edge of the moon. So that is the best time to try and spot a bit of turquoise. So we're going to keep our eye on things here. Don't really see the blue in this eclipse.
So keep an eye on that beautiful image from Perth there, because that's not going anywhere. You're not going anywhere. We're going to keep on looking at these beautiful feeds from all over the world. We're going to be back in 20 minutes or so to talk to Steffen Thorsen, our chief eclipse chaser here at timeanddate.com. He's in Yucca Valley in California with Konstantin, who we talked to earlier. So don't go anywhere. Keep your eyes looking for that blue tinge on the moon, and we will be back soon. We're still watching a total lunar eclipse here on timeanddate.com, and we are nearing the end of this eclipse. The moon is moving out of Earth's dark shadow. We can see there on our timeline that things have calmed down a bit in the totality dark red area there. And the partial phase of this eclipse will end about 45 minutes from now or so. We're still enjoying images from around the world. We've got Southern Hemisphere represented by Dunedin and Perth, and then we have the Northern Hemisphere represented by Yucca Valley, California. And in Santa Fe, we've had our good friend John Williams streaming from New Mexico there. He goes back many years with us. We met him personally in Roswell, New Mexico during the Great American Annular Eclipse back in 2023. If I remember correctly, it's his fourth time?
It's John's third time with us, yeah.
Working with us. So we've been having great friends from around the world time round. The person who started all this eclipse chasing for Time and Date, he started Time and Date as well 3 decades ago. It's Steffen Thorsen. He is who we call our chief eclipse chaser. And this is the 18th time he's taking the mobile observatory out on the road from Stavanger, Norway. And we're going to have a talk with him now. Hi, Steffen.
Hello, Graham. Hello, Anna.
Oh, this eclipse is visible anywhere from the nighttime side of Earth. But how did you end up in Yucca Valley, California then?
First of all, I'm impressed by Graham still counting my eclipses because I've stopped I don't have the count anymore. But the reason we went to this area is obviously the weather forecast. We basically got tickets back in May last year for California, so we kind of had the rough plan early, and California was chosen because on the kind of this eclipse being visible mostly over the Pacific and on the east and west side of that, more or less opposite of our location on Norway. You did have to go quite far to get to an eclipse. And this area in California, Arizona, Nevada generally had the least cloud cover averages, and we use our own cloud cover maps on the Time and Date eclipse pages to judge where to go. And we flew in here, and it was a very good choice. We sometimes have to drive for hours. As Konstantin mentioned earlier, this time was just 2 hours, so it was a kind of very nice trip. And Yucca Valley is behind or east of the mountains. So if the LA area has clouds, very often this area won't have clouds. And exactly that what was happened today. There was clouds most of yesterday, so we were a bit worried if the forecast was correct, but it has been really great this night.
Yeah, nice. And great images you've been sending us there. Now, Steffen, we always get lots of questions about what kind of equipment people are using for doing these live streams. So for the astronomy enthusiasts and the telescope nerds, can you tell us about what you're using to stream this eclipse tonight?
Yes. First of all, since we're traveling with planes, we need to find equipment which is small enough to be able to relatively easily be carried along with us. So the biggest telescope we can easily fit is a 6-inch telescope, which we use for especially the eclipse totality phase, because it is with a 6-inch aperture, it catches a lot of light and it's easier to get a good glimpse of the dark side of the moon. And we have a 3-inch telescope, which is the one we're currently seeing in the main screen, which is the bright side of the moon doesn't need so much light, so a 3-inch telescope does a really good job just on the bright side of the moon. And it's nice to be able to catch them both at the same time because it's very different views of the bright and the dark side. In addition to that, we also have like a bit of small cameras, GoPros, and things for just watching or take time lapses of the entire eclipse. And we also have a video camera or DSLR that we'll use later to film the sunset coming up at the end of the eclipse for us here in Yucca Valley.
Yeah. Now, I mean, you've mentioned sunset, sorry, moonset approaching.
Moonset, sorry, moonset. Yeah.
Because what it's 4:30 in the morning local time for you, so we are getting towards the end of the night there in California. The moon is getting lower in the sky. When and where is the moon going to be setting for you tonight?
Now we as said, we are east of the mountains, so we kind of fantasized about having a place where we could kind of see the moon setting over the Pacific Ocean, which would be fantastic. But then we would have more of a. We had more luck with clouds, so we went for something a bit more secure in terms of the weather. So the moon will be setting behind some great peaks, about 20 miles, 30 kilometers from here, at about 1 hour and 24 minutes. 20, yeah, from now. And we hope it might be a nice sight because it's some of these mountains also have snow. So we hope for a very nice, also as the mountains will be brighter in a way when the sunrise is about to soon happen. Yeah. So we think it would be nice.
Yeah, that's great. And just to be clear, the plan is to keep the cameras running and to keep the telescope going all the way down until moonset.
Yes, that's the plan.
Yeah.
So keep staying on.
Yeah. Okay. And so, I mean, in UTC time, I think that's happening around about then 13:57 UTC. So we still have what 45 minutes of this partial eclipse to enjoy. But then after that's finished, we still have this, fingers crossed, we have this this great moonset to look forward to.
So we've still got a lot to look forward to, as Steffen reminded us there. Thank you so much, Steffen. We want to keep
and I might
watching.
mention the moon also. The moon might be a bit red again because of getting kind of low in horizon. So it's a bonus tint color. Yeah.
True. Bonus red moon. It's awesome. So keep watching to see that bonus red moon. And don't forget to look at our eclipse pages, a night sky map, and our other astronomy tools on timeanddead.com. Don't forget to hit subscribe. There's a lot of fascinating eclipses coming up in the future, and we will see you back here soon on timeanddead.com. Welcome back to timeanddate.com. We are nearing the end of this lunar eclipse, but don't go anywhere. A full moon is always great to look at. I'm excited about the full moon, and we have moonset in California coming up in about an hour. But this is kind of the last total lunar eclipse for a while, right, Graham?
Yeah, so we see these patterns in alignments of the Earth, Moon, and Sun. For a couple of years now, we've had a very nice run of total lunar eclipses. Tonight's eclipse, that was the third total lunar eclipse since March last year, but it is the last one for almost 3 years.
Yeah, but almost, Graham, almost, because there is not a total, but...
Well, that is very true. That is very true. At the end of August this year, on August 27th, 28th, we have a very deep partial lunar eclipse. We're going to see it's about 96% of the moon's face is going to get covered by the dark inner part of Earth's shadow. It's not quite 100%, so technically it doesn't qualify as a total lunar eclipse, but when we see it in the sky, to all intents and purposes, it is going to look like a total eclipse, and the moon will take on that reddish color that we've been enjoying tonight.
Yeah, we have. It won't stay red for an hour, or it won't stay red that long, will it?
It's not going to stay red for as long, and it's not going to be as deep. But it will take on. It will take on a reddish tint. Yeah,
it's still a good eclipse.
Absolutely. For the next kind of official total lunar eclipse, where the whole of the moon's face gets completely covered by Earth's dark shadow, well, that's coming up on it's a kind of a special date. It is December 31st, 2028. Now it depends a bit on your time zone, but for some people this is almost the perfect New Year eclipse. Anna, right now we're looking at these pictures from our friends Matt and Roger in Perth. In Perth's time zone, this next total lunar eclipse, totality, will begin at midnight on January 1st, 2029.
A proper New Year's eclipse.
Yeah, so I mean, just to be clear, that is like 15 minutes after the big countdown to 2029. Totality will begin in the skies over Western Australia.
But that's in 2029. We've had a good run of lunar eclipses now, and that means that we're getting some good solar eclipses, right? Because for every not so perfect lunar eclipse, we get a so perfect solar eclipse, right?
Right. So coming up just over 5 months from now, on August 12th, we will be broadcasting a total solar eclipse live from Spain. Now, this is going to be the first total solar eclipse in mainland Europe since 1999.
1999. So this is a good time to travel for solar eclipses, right? We're getting some great ones across the globe.
Absolutely. This is, we're kind of entering a bit of a golden period for solar eclipses. So yeah, August 12th this year, totality in Spain and also in Iceland and some parts of Greenland. 12 months after that, on August 2nd, 2027, a total solar eclipse. Again, the path of totality will go across Spain. It then goes over North Africa and the Middle East. A year or so after that, on July 22nd, 2028, another total solar eclipse. For this one, totality is going over Australia and New Zealand. This one includes almost 4 minutes of totality in Sydney, Australia.
Very, very excited about that. And we often refer to solar eclipses as rare. We've talked about 3 beautiful ones coming up now. So So rare, but in fact, we have published a paper on that. It's going to be published in the Journal of the British Astronomical Association, right?
Right. So, I mean, on average, a solar eclipse happens somewhere in the world every 5 months or so. But if you stood at a random spot on the Earth's surface, how long would you have to wait for a solar eclipse to happen? That is a much more complicated question. And well, we had a lot of fun looking into this. We were building on work done by a very famous mathematical astronomer named Jean Mears. And well, for the record, the results of this were that for any given place on the globe, a total solar eclipse that happens once every 373 years on average.
On average. So if you stand in one spot and then I hear your voice in my head saying on average, it takes 373 years for a solar eclipse to hit you. On average.
On average, you might get lucky, and of course, we know there are some places in the world that have a very lucky run where they have 2 total eclipses separated just by a small number of years. Other places, have to wait hundreds of years for a total eclipse to happen. But yeah, on average, once every 373 years.
So they are rare.
So that definitely is rare. If we're talking about partial eclipses, then again, if we're just talking about a given place on the Earth's surface, so your town or your city, for example, a partial solar eclipse that comes around on average once every 2 years and 7 months. So looking at it from that perspective,
not so rare,
right? Not as rare as we sometimes imagine.
But if you travel, you can put yourself in the path of a total solar eclipse.
That's right. There we're talking about just taking a random spot on the Earth's surface and saying how long does it take for a solar eclipse to happen. Absolutely, yeah. Especially for total eclipses, a lot of people don't get the chance in their own town or city in their own lifetime. So for nearly all of us, the only option is to hit the road and travel for totality.
And there are some people that have hit the road for us on timeanddate.com. Now, in Santa Fe, New Mexico, John Williams, we want to say thank you to him. We want to say thank you to Preeti Krishnamurti and Avinash Surendran in Waimea, Hawaii. We want to say thank you to Roger Groom and Matt Woods in Perth, Australia. We want to say thank you to our mobile observatory team in Yucca Valley, California, Steffen, Thorsen, and Konstantin Bikos. We're excited to have you back home here at Stavanger HQ.
And we also can't forget, of course, we did see that great bonus.
The bonus
footage.
From Dunedin, New Zealand.
Right, from the Dunedin Astronomical Society. Yeah. And thanks to everybody there.
Yeah. And at Time and Date HQ, we'd like to thank the crew. We've got Jeremy Krause, Ardian Rexai, Andy Ardner, Daniel Leland, Anna Smith, Ellie Elliott, Sarah Kornberg, Renate Mellanhus, and Ina Maria Thorsen. Don't go anywhere. We're still going to enjoy the end of this partial stage of the eclipse. We're going to follow the moon set, probably kind of nice.
Yeah, and again, just to recap, around about 1357-ish UTC, that's when we're expecting to see the moon setting behind the mountains as seen from Yucca Valley, California. So still a lot to come.
So, but for now, it's goodbye from me and Graham. We're gearing up to travel to Spain and show you the great European total solar eclipse on August 12th. So from us, it's bye-bye, but stay on and watch the moon a bit more. Time and Date, we look up into the sky. We bring you exclusive footage from eclipses worldwide. We take our mobile observatory to where the action happens. Hi, Steffen.
Hi, Anna.
We collaborate with experts and observatories across the globe to bring you the best view of celestial events.
And we ordered the Devil's Horn just for you.
Now, we have to say thank you very much for your images tonight.
We explain how and show why it all happens while answering your questions during our live broadcast events.
That is a meteor.
Find your home and even more details on Time and Date. And subscribe to join us next time.